Okay, so the purpose of this video is to pick up from where we left off, from the Isocost and Isoquant, and we'll be talking about the long run and short run total cost curves. Now, this video is going to be very important because this is going to determine how well you understand things like the marginal cost curves as well as the average cost curves for the long run and the short run. So pay attention, okay? So, what are total cost curves? They're simply curves that display all the total costs that a firm or business can incur when they produce various quantities of X in the long run as well as in the short run. Now, there will be bound to be some confusion between what it means by the long run as well as the short run, so we're going to go through this in a little bit. Alright, we're going to start with what the curves look like first, so just let me show you what the total cost curves are. So you have a graph with the total cost on the vertical axis and quantity on the horizontal axis. So that's your long run total cost and that is your short run total cost. So one of the things you should be asking is, why do they meet here? Right? Why do they intersect at this point? So we're going to find out how we're going to be deriving these total cost curves. So using some rational deductive logic, you should be wondering what can give me the total amount of cost for this amount of quantity produced. Well, if you've guessed the isocost, then you're right. And you're also going to need the isoquant because the isoquant tells you exactly how much quantity of X is being produced, right? So this is where we're going to pick up from the last video. Okay, so we're going to do a little bit of recap on what is the isocost and the isoquant and how they work out between each other. Okay, just let me quickly draw a graph with capital versus labor, and just right below of it, I'm going to draw another graph with the total cost versus the total quantity of X produced. So let's say I'm interested in producing three quantities of X. I have X0, X1 and X2. Obviously, as I move towards the right side of the horizontal axis, I'm increasing the production of X. So now I want to find out what would be the total cost for producing each quantity of X. Okay, so to show my quantity, I'm going to have to use isoquants, right? You got isoquants X0, X1 as well as X2. Okay, you should really understand how isoquants work. So how do we find the total cost using the isocost? Well, I hope you recall the concept of the long run expansion path, because this expansion path contains all the points where the isocost is tangent with the isoquant, just like what you see over here. Okay, so these are the 3 points that the firm will be producing at. This is going to show the amount of labor and capital they're going to need to be producing these quantities of X0, X1 and X2. So just to be a little bit meticulous, to produce X0, the firm is going to need L0 amount of labor and K0 amount of labor. To produce X1, it's going to need L1 amount of labor, K1 amount of capital. To produce X2, it needs L2 amount of labor and K2 amount of capital. So here's how I'm going to find out what is the total cost to produce certain quantities, right? So to produce X0, I know that the total cost is going to be the amount of labor multiplied by the wage rate plus the amount of capital multiplied by the interest rates. I hope that's familiar to you. So let's imagine that there are real numbers there, so we can find out what C0 is. So we're going to mark out C0 over here for X0 quantities of X produced. Okay, so that's how we find the total cost. So how about the total cost to produce X1? Well, it will be C1 equals to the amount of labor, which is L1, multiplied by the wage rate plus K1 multiplied by the interest rates. Now it should be obvious to you that C1 is more than C0 because the isocost from which X0 is produced is lower than the isocost from which X1 is produced. Notice this isocost and that isocost. So going back to the graph below, I know that C1 is going to be somewhere there for the quantity of X1 being produced. So I'm just going to do the same thing up to C2, which is the total cost for X2 being produced, and there I have the total cost. Obviously, the total cost has to be increasing when you're producing more of it, right? So what you're going to do is to connect the dots to get the long run total cost. See, is that easy, right? So now that we've bitten the the long run total cost, let's talk about the short run. So you know that in the short run, capital can be fixed at maybe say K1. So that is your short run expansion path. So this is the points where all the isocosts and isoquants are going to be tangent in the short run, like you see over here in the red isocost. So in the short run, to produce x0, a firm is going to need to use L0 and K0, which is the same as a long run K1. And to produce x1 is going to need L1, and to produce x2 is going to need L2. So they're all going to be using K0 amount of capital because it is fixed at that point. So to produce x0 amount of x, the total cost is going to be L0 multiplied by W0 plus K0 multiplied by the interest rates. So obviously C0 is going to be bigger than the C0 in the long run because the red isocosts are all higher than the purple isocost. So going back to my total cost curve, I know that C0 red is going to be higher than C0 purple. Okay, so I'm going to do the same for the production of x1. Sorry, just typo error there. So C1 is equals to L1 multiplied by W0 plus K0 multiplied by R0. So C1 is equals to C1 in the long run because this is where both the long run expansion path as well as the short run expansion path is going to meet. They both share the same tangent point, the same isocost and the same isoquant. That means your long run total cost is equal to your short run total cost. Please remember that. I swear on my that this is always true all the time. The point where the short run and long run expansion paths meet is where the total cost for the long run and the short run is going to be the same. So in that case, C1 for the short run and long run is going to be the same for the production of x1. So we'll just finish up for the production of x2. So the total cost for producing x2 in the short run is going to be C2, and C2 is obviously higher in the short run because of the same reason that we discussed previously. The red isocost is higher than the purple isocost. Therefore, C2 is going to be somewhere there, okay? And we have now found all the points for the short run total cost. So this purple line over here is the long run total cost, and this red line over here is the short run total cost. Notice that both lines intersect at x1, and that is because this is where the long run expansion path meets the short run expansion path. These curves are pretty ugly, but they're just for demonstration purposes. Notice that the short run total cost must start above the origin, and this is because in the short run, capital is not fixed, therefore they incur a fixed cost even when they produce 0 units. So just let me show you a positive demonstration of the curves. So on a graph where you have got the total cost against the quantity of x produced, this is what the long run total cost curve is going to look like. And you have the short run total cost curve over there. And this point is the intersection point where the long run total cost equals to the short run total cost for a certain quantity of x. And this is because this is where the long run expansion path equals to the short run expansion path. I have no idea how you're going to forget this because I've said it about 3 times. Okay, now just let me bring your attention to the short run and the long run. And we're now going to discuss what is the difference between the long and short run. Now, let me just rub this away first because it's in the way. So a lot of students might think that the short run is where the quantity of x produced is lesser, and in the long run, the quantity of x produced is more. Now, this is not the case. This is not true at all. Let me explain to you what is the difference between the long run and the short run. So in the short run and the long run, the quantity of x produced is actually the same, okay? So it's not about the different quantities. In fact, it is about the time frame or the time range, and the time range is not the same. Okay, so let me give you an example. Let's imagine I'm producing 100 units of X in, say, maybe 1 year or 10 years. So what we're talking about is what is the difference between producing 1,000 units in a year and producing 1,000 units in 10 years. So that is the difference between the long run and the short run. So obviously 1 year is going to be the short run and 10 years is going to be the long run. But are these numbers fixed? Is it always 1 year or 10 years? No. Well, in the short run, what we mean is that the firm cannot easily buy or sell machines, okay? Therefore, we can conclude that in the short run, capital is fixed. And in the long run, yes, we can easily buy and sell machines. Therefore, the amount of capital is going to be flexible. So as you can see, 1 year and 10 years actually depends on the flexibility of capital. So that is how you differentiate between the long run and the short run. Now, the next question that you might be asking yourselves is, why are the total cost curves so curvy-woovy? Well, that's because the behavior of these cost curves are subjected to certain laws. Okay, there are typically two types of laws that the cost curves have to follow, and they are the law of increasing or accelerating marginal returns. Okay, so that is the first law, and the second law is going to be the law of decreasing or diminishing marginal returns. I have a feeling that some of us might not be so clear on what it means by marginal. So I'm going to use a simple example to explain the concept of marginal. Okay, so let's say we've got quantities of X and the total cost. I'm producing 1, 2, 3, 4, 5 quantities of X. So to produce 1X, the cost is going to be $5. To produce 2X, the cost is going to be $10. And to produce 3X is going to be $14 in all, so on and so forth. So now I'm going to add a column to the right, and that will be marginal cost. And you will notice that I'm going to take the difference between each increment of the total cost. So I've got 5, 4, 3, and 2. So that is how I get my marginal cost. So that brings me to the definition of the marginal cost. Marginal cost is simply the additional cost incurred for every additional X I produce. Okay, now that you've understood the meaning of marginal, let's go on to the increasing or accelerating marginal returns and what this means. Simply, if I were to increase my inputs to produce stuff, I'm going to see an increase in the marginal product. Okay, so there's going to be an increase in the marginal product, or while I produce more output, I might see a reduction in the marginal cost as I produce more output. Okay, so that is what it means by increasing or accelerating marginal returns. That also means if I were to draw a graph with the total amount of product on the vertical axis and the amount of inputs in the horizontal axis, I'm going to get a total product curve that looks like this. As you can see, it is getting steeper and steeper as I put in more inputs. You will notice that the gap, okay, between the increase in input is going to be much smaller than the gap in the increase in output. So A is going to be smaller than B, or B is going to be bigger than A. Okay, so that's what it means by increasing returns. Now, for the total cost, you will see a curve that looks like this. You will notice that it is getting flatter and flatter, which means that the more X I produce, the slower the increase in total cost. Okay, take a look at this gap A and this gap B. A is going to be bigger than B because of this increasing marginal returns. So this is also known as economies of scale. I'm pretty sure you have heard of this. Now, few reasons for economies of scale is due to learning by doing. So people become more efficient in the way they do their jobs, and they have lesser wastage, and they can produce more with lesser time. And it might be also due to bulk discounts on supplies or inputs. So the more inputs I buy, the cheaper it's going to cost me. On the contrary, for decreasing marginal returns, as I increase my inputs, I might see a decrease in marginal product. Or as I increase my output of X, I would see an increase in marginal cost. So what the curves are going to look like is simply the opposite of what you have seen. So your total product curve is going to be getting flatter as you reach to the top, because the more inputs you have, the slower the growth of your total production quantity. And you also notice that for your total cost curve, it is getting steeper as we produce more X, because the more X we produce, the faster the cost is going to increase. So this is known as diseconomies of scale, and it might be due to a business being too big to handle, or the company might be overworking its resources. So workers are going to get more tired, so they work slower, machines might break down, so you start to fuck up after producing too much. So now let's talk about the word returns from what you just learned. So typically there are two types of returns. Okay, the first type of returns is called returns to factor, and the second is called returns to scale. Now, there's a major difference between the two of them. For returns to factor, this only applies in the short run, and that is because capital is fixed. You will realize that labor is variable in the short run, and that means that your returns is going to vary with the amount of labor you put in. So labor is only one factor, it's the only factor that can be variable, so therefore returns to factor refers to the short run because only one of the factors can be changed. So returns to scale only occurs in the long run total cost because of capital and labor being flexible. So it is a scale of capital and labor. Therefore, returns to scale refers only to the long run. So just let me show you how this phenomenon of returns actually looks like on the graph and where it takes place along the long run total cost curve as well as the short run total cost curve. Okay, so let's start with this blue portion that you see over here. This is actually increasing returns to scale because it is in the long run, and you see that it is getting flatter and flatter. My marginal cost is decreasing, my total cost is increasing at a slower pace as I increase the amount of X produced. Now from this portion to that portion where the long run total cost curve is getting steeper, this is called the decreasing returns to scale portion. And in the middle where it is 45 degrees, that is my constant return to scale. My total cost is going to increase 1 for 1 for every quantity of X that I produce. Now, let's take a look at the short run total cost. This red portion over here is increasing returns to factor. And here, this is decreasing returns to factor. There's a typo error. It shouldn't be an S, it should be an F. My very sincere apologies for that. And this middle portion over here where it is 45 degrees, that is going to be my constant return to factor. Okay, awesome. We are now going on to the last branch of this mind map, and we're going to talk about the different types of cost. So the first type of cost you should be aware of is the cost that is called variable cost. And variable costs are basically the costs that change in proportion to the quantity of goods being produced. That's why it's called variable cost. So some examples would be labor. Labor is a variable cost because we pay them wages, and that might increase or decrease. Material costs might be one of them. Overheads, both indirect and direct. So you got things like your water bills as well as your electricity bills. So now let's move on to the other type of cost, which is known as fixed cost. So what are your fixed costs? Your fixed costs are basically the costs that are independent of the quantity of goods being produced. Now, this is sometimes the number one killer of businesses because sometimes when the economy is not doing well, they don't have enough revenue to cover their fixed costs. Okay, so examples would include machines, vehicles, factories, equipment. Factory is one of them because you have to pay rent, and whether you produce or not, you're gonna have to incur that rent, and rent can be freaking high. Singapore is one of the examples where your rent is extremely high. And that's really what's killing businesses. That's why a lot of people are going to e-commerce and things like that. So your fixed cost is fixed at a certain amount regardless of how many units you produce. Your variable cost will be increasing as you produce more of that good. So this blue line over here is actually your total cost depending on how many units of that good you produce. So what if fixed cost is going to increase? The green line is going to shift upwards in a parallel fashion. The blue line is going to shift upwards in a parallel fashion as well. So that is going to be your new total cost curve. So what if there's an increase in variable cost? The blue line is going to become steeper because for the same amount of goods you produce, you're going to have to pay a bit more. So what does this mean for your curvy-woovy cost curves? Well, it's going to be the same. Let's just focus on the short-run total cost curve, okay? Let's assume that there's going to be an increase in fixed cost. Okay, so there's going to be an increase in fixed cost. What happens is similar. Your short-run total cost curves is going to shift up in a parallel fashion, okay? So that is what's going to happen when there's an increase in fixed cost. What about a decrease in fixed cost? So the opposite is going to happen. You're going to see a parallel downward shift of the short-run total cost curve. Now, let's take a look at the other type of cost change, which is the change in variable cost. So let's say there's an increase in variable cost, your short run total cost is going to increase in its gradient, it's going to be steeper. And when there's going to be a decrease in the variable cost, your short run total cost curve is going to become flatter. So that is the two very simple dynamics of your total cost curves. And from there, we have reached the end of the video. I thank you so much for starting with Quickienomics. I'll see you in the next video where we're going to talk about the marginal and average cost curves.